welcome to uh, the weather, which we can enjoy today. Um, nice cold day. Okay, so our speaker today is Ben Nelson, who is the senior meteorologist at the Jacksonville office of the National Weather Service, which is a part of NOAA. And his work involves preparing forecasts for the region, managing, training, and promoting Skywarn, which is a storm spotter network. And he's also part of the Florida Emergency Management Team and trains the members, team members on weather-related issues. He grew up in Virginia, went to FSU to their meteorology program, and he lives. He said, "Don't say that." And he lives in St. Augustine, and he was kind enough to drive all the way over here today. So we really appreciate his coming and talking about the weather. Thank you.
All right. Thank you, Jane. Appreciate the introduction. I am a little familiar with retirement communities. My parents, when I had the first of my three daughters, they moved from Virginia down to the Villages. So we are frequent visitors to that huge retirement community just to the south of you guys here. But you guys have a very nice place here. So I appreciate the invite, Jane. And hopefully this will be beneficial for you guys. This afternoon, we'll talk about all different kinds of weather. And again, we'll have some questions at the end if anything comes to mind. It's pretty ironic. I put a big picture of a hurricane up there, and we're having just about the opposite type of weather here for the speech. But thankfully, this past hurricane season, unless you were in Jamaica, right, with Melissa, everything stayed out to sea. And we had a question about that, and we can kind of delve into that later into the talk. It has all to do with steering currents, real technical term, but they were in our favor this year, to say the least. So we're real thankful about that. It only takes one storm to make it a bad season. So it's good to be prepared as we look forward to warmer weather. But that warmer weather, of course, brings tropical storms and hurricanes once we get deep into the summer. So let's see if I can get this. Okay, there we go. So if you've ever wondered, again, I work for the federal government. As Jane said, the National Weather Service is just a kind of a real small agency overall in the big federal bureaucracy, right? We're part of the National Oceanic and Atmospheric Administration. NOAA has the fisheries part, the oceans, right? Nobody likes that part of NOAA. That's the part that tells you can only go out and, get one or two redfish, once a year or something like that. So we're not involved in that at all. Obviously, we're the ocean, the atmosphere part of NOAA. And our agency, mission statement is to issue watches, warnings, advisories, all in an effort to protect life and property. I think the property part comes from the fact that we're part of the Department of Commerce. A gentleman there used to work for the Department of Commerce, correct? Somebody did back in here. So, but yeah, the Department of Commerce being the agency that's part of the president's cabinet, we got that part about protecting property as well as life in our mission statement. So just to kind of spice things up a little bit before I go into maybe a little bit more detail about the National Weather Service, you guys are not surprisingly under a freeze warning now. When I made this graphic yesterday, it was a freeze watch, but this is an example of some of the forecast products that we issue on a daily basis. Our forecast window is the next 7 days. So weather is more of a next 7 days type of time frame. Anything beyond 7 days is more of a climate forecast. And there is a part of NOAA and the National Weather Service called the Climate Prediction Center that handles that time frame beyond 7 days. But at the field office level where I work up in Jacksonville, we're just handling the next 7 days. Tell you, I don't know if we've got any longtime residents here. I'm trying to remember a winter that was this, this active and this cold and also dry. And I've been in Florida for I was just telling Jane, 31 years. I'm originally from Virginia, but the only winter that I can really remember that had this number of Arctic type blasts was 2009, 2010. And I remember that very well because I had just entered the National Weather Service back then. My first office that I worked at was down in Key West. Key West is a very expensive place to live. So my wife and I ditched a car when we moved down there. And if you've ever been to Key West, anybody want to answer what's the main mode of transportation in Key West? Well, it's a boat, yes, boat. But getting around town, everybody's got scooters. So I picked like the coldest winter ever to have a scooter for my primary mode of transportation. Let me tell you, when you get on that scooter and it's in the 40s and 50s and there's a lot of wind, it's no fun. So this winter reminds me a little bit of 2009, 2010. It's been a good 10 or 15 years since we've had this, these repeated type of cold outbreaks. And, it might be tough to see up there, but we're talking about wind chills this weekend as a coastal storm potentially spins up off the Carolinas. That's going to drag even more cold air down. We're talking about wind chills Saturday night, Sunday morning, down around 10 degrees, which is not something that happens each and every year. So, part of our forecast process is to try to get folks prepared, to endure, a long cold spell like this. And certainly, one of the things that we see happen when we have cold outbreaks is a lot of home fires, mainly from people misusing things like space heaters, right? Putting them up, too close to drapes or anything like that, or just using a faulty space heater, not giving it enough room between the unit and the wall. So we kind of preach that sort of preparedness, getting folks thinking about practicing fire safety. Obviously, plants. I'm getting tired of covering all my plants every night in St. Augustine in the yard. And just your pets, outdoor pets, bringing them in. That includes things like we're talking about all sorts of folks in our area. We got a lot of farming here in North Central Florida, so livestock concerns, that sort of deal. So we're going to really see that this weekend with this next little blast of cold air coming in with this coastal storm spinning up off the Carolinas. And our area that we cover includes South Georgia. We have about 32 counties that we're forecasting for the next 7 days. And up in Georgia, there's actually probabilities at this point. They're low probabilities, but for a little bit of snow circulating back into our area sometime on Saturday. So that's something we'll really be watching because there's just not the infrastructure down here to deal with snow. I think the Florida Panhandle now has had 3 straight winters of accumulating snow west of Tallahassee, but there's not that many snowplows in Florida, and there's more in Georgia, but they have, Georgia's a big state. They have to allocate resources down to South Georgia, which they don't do very often. So that's just an example, that image there of current snowfall probabilities, and really any type of sleet, freezing rain, winter type precipitation. So we're not done with the cold spell. In fact, the Climate Prediction Center, I was looking at their products that go out to the next 3 to 4 weeks, and these below normal temperatures are going to stick with us. So this is a real winter we're having here this year, and it's, like I said, it's been about 15 or 16 years since we've had a real sustained winter cold like this. So again, our agency, is science-based. We like to say it's a combination of science and service. We are collecting data. Anybody have an idea of one of our main data collection platforms? Yes, sir. Yes, satellites, absolutely, satellites. We're also launching weather balloons twice a day up at our office in Jacksonville. So we're collecting all that sort of data. Obviously, we have our Doppler radar up there at Jacksonville too. You guys are kind of between radars here. There's a radar in Tampa, there's a radar in Melbourne, radar in Jacksonville. So again, we are using that data, particularly when we have thunderstorms and heavy rainfall to produce our thunderstorm and flooding products. So we collect all that data from the weather balloons, satellites, radar. We synthesize that, issue forecasts for all those counties, 32 counties in Georgia and Northeast Florida, out to the next 7 days. And again, our goal in all of this whole forecast process is to get folks thinking about how they can be prepared for significant weather hazards. So again, the National Weather Service, there's a lot of these field offices. There's 122 of them. Again, this is, we're just one of, again, 122 in Jacksonville. All across the country, all of these are very similarly staffed with about 15 meteorologists at each office. We're working round the clock. I'm a rotating shift worker, which is tough with the kids and family. Last week, I did 7 straight shifts of 10 p.m. to 6 a.m. So this week, I'm trying to get back to the real world where I'm not sleeping during the day. So again, this job is not for everybody. We're not on TV or anything like that. But we do work very closely with our television broadcast meteorologists. They go hand in hand, and we're in constant communication because the folks who are on television, they help us get that word out when we do have severe weather and warnings. So kind of zoomed in. Here's a picture of our office up at Jacksonville. We're kind of near the Jacksonville International Airport. All these offices, again, on that map I showed you, they all kind of look the same, all built back in the 1990s. And all these offices were, there was this quote unquote modernization of the National Weather Service back in the 1990s when we instituted the latest Doppler radar technology. So all these offices that you see across the country are all kind of built around where the Doppler radars are. And this is back in the 1990s. So all these Doppler radars are starting to get a little bit long in the tooth. Any kind of think about a piece of technology that's constantly spinning around for 30, 35 years. They're looking at the next step as far as the next iteration of Doppler radars. And this map might change a little bit as we go to a newer technology in the future. But as with anything with the federal government, it's going to take, it's more of a glacial change type pace, not immediate. So again, here's the specific counties that we forecast for. I put an example of a rather large severe thunderstorm warning up there that again we would be issuing if we saw the signatures on our Doppler radar, if we had reports from our emergency management community, public safety, or even trained storm spotters who we employ or we get to volunteer to help us out when we do have severe weather. And so again, here's our team. It's not the biggest group of folks, and each of these offices that I showed you up on the map, we're kind of similarly staffed, where we have 3 managers, we have about 13 or so meteorologists, and then we've got folks who are repairing the equipment. We've got the Doppler radar on our site, we've got administrative staff, and we actually even have a meteorologist who goes out to cruise ships and any other type of ships at Port Canaveral and Port Jacksonville and helps put instrumentation on them so we can know what's going on in our marine waters as well. We're also forecasting for the marine waters out to about the Gulf Stream, about 70 miles offshore. So again, when you're looking at forecasts, these are all the different types of forecasts that these offices are issuing. You're probably most familiar with the public forecast. Goes out to the next 7 days. It's real specific to Alachua County. But again, we're also producing forecasts, let's say, for airports. There's 5 airports that we're forecasting for, one of them being Gainesville Regional Airport. We're also forecasting, like I said, for the marine waters. And this time of year, we really get involved with the Florida Division of Forestry and the U.S. Forest Service. If you've come to Florida from another state, This state is really, really big on managing the forests around here. So they do that via prescribed burns. And obviously weather has a huge impact on those type of operations when the forestry folks are trying to manage the forests. This time of year, they like to do it before we get into our lightning season. This dry weather, it's a little bit too dry in a lot of cases for there to be prescribed burns, but they still go on, and we assist with each and every one of those prescribed burns that goes on. We're providing a forecast for both our federal and state forestry folks. So again, we collect all the observational data. We analyze that with the help and the assistance of computer models. And the big thing that's changed in the past couple of years is we're starting to get the artificial intelligence, the AI models that did really well during this past hurricane season with each and every storm. So that is really exciting, right? We can really leverage this artificial intelligence. I know it's got a bad rap, for a lot of things, but I think for weather, if we could, the vision in the future, if we can know a week or two in advance where a tropical storm or hurricane is going to make landfall, thanks to an AI model that's really accurate, that's going to really improve the whole process, preparing, recovering from these storms. So we use that model data to produce our forecasts, and then we distribute those forecasts out to not only the public, but again, our emergency management community around the state, public safety officials, forestry folks, aviation. They're all our customers of our forecast products. So when we talk about observations, again, I think we kind of nailed it earlier with satellites, radar. This is an example of radar reflectivity. It's just looking at how intense the precipitation echoes are. But our Doppler radar can also detect air motion, air that's going away from the radar site, air that's coming towards the radar site. That's what really sets that radar technology apart from prior technology that we had way back in the 1950s, 60s, and 70s. These radars are way more advanced. And again, this is all kind of feeding into our forecast process. One of the things that we still do, this goes all the way back to the World War II era, when folks started launching weather balloons, and we put this instrument package called a radiosonde. We tether that to a weather balloon, and at right now when we're on standard time, we're launching at 6 a.m., 6 p.m. In March, when we go flip the clocks forward, spring forward, our launches will be at 7 a.m. and 7 p.m. This gives us a really, really good, quick type of snapshot of just what's going on in our atmosphere. Those radiosondes are measuring temperature, pressure, humidity, and we're putting a GPS, global positioning satellite lock, on that radiosonde to track it. And those GPS satellites are so accurate that we can actually derive the wind direction and speed that's going on up in the atmosphere just by putting a satellite lock on that radiosonde. This is the data. This is called a SKU-T log P diagram. The red here is the temperature trace, and this is the humidity trace. So whenever these two lines are close together, you have a saturated atmosphere. You can see how things really change. This is the flight level approximately on this graph. And so things are really saturated in the lower part of the atmosphere. And as it went up, it got much, much drier in this example. So I like launching the weather balloons. We get to go outside, and we kind of have a little rural area around our office. It's not, there's not a lot of power lines or anything like that around. So it's kind of nice to get outside away from all the computers and experience nature when we launch those balloons. The balloon usually gets up to about 20 miles high. It takes about 2 hours for it to ascend that height. And then it bursts and comes back down towards the ground. So again, this is when you're talking about a balloon that we're filling with hydrogen, going up there for 2 hours. It gets up to almost 20 miles high, in some cases higher. And when you get up that high in altitude, the pressure is so low that the balloon expands and expands. It actually gets 20, 25 feet in diameter. before it bursts. And we've got the parachute that we're attaching to that. There's about 800 locations worldwide. They're all launching weather balloons at the same time, so we can get all of that temperature, pressure, humidity data all flowing into the computer models at the same time. Again, we're one of the stations in Florida that's doing this, and hopefully we'll continue to do it. It's pretty fun little experiment each time you go out there. Oh, here's a nice little video. My colleague getting ready to launch the balloon. See the parachute there. This is obviously an evening launch. There's the radio sign there at the end. The radio signs have gotten smaller. Taking this video, they're really, really tiny now. It's pretty amazing.
Is this a good spot?
It looks good. Yeah, it's going to go northward. So, yep, good to go. We're on a good time.
We have to call the airport before we launch.
There it goes.
Make sure we're not going to launch when the plane's up.
Like a pro. There it goes, way up. Boom.
I think that was my coworker's page. It's probably one of her first times launching the balloon. So, all right, so that's the weather balloon. Let's talk about radar. Again, this is there's a lot going on inside of this dome here. We got pulses of radio wave energy that are being sent out several times per second. And what we're doing is in a given hour, this Doppler radar is sending out those radio wave pulses for only 7 seconds. The rest of the 59 minutes, 53 seconds, it's in listening mode. It's waiting for that radio wave energy to strike an object, whether it be a raindrop, a hailstone, it can be a bird, a bat, insects. This thing picks up a lot of stuff, and it sends that energy back to the radar for it to process. So, and it's not only, sending out a radio wave pulse, kind of close to the ground, but we're getting pulses that get sent out throughout the atmosphere. So it's almost like an X-ray of the atmosphere that we get from the Doppler radar. And I mentioned you guys here in Gainesville, you're kind of in between radars. There are some limitations to the radar. One of them being the further away you are from the radar, the less of those low-level features that you get. So that's why we go out and do storm spotter talks. We make sure that we've got eyes and ears on the ground. So if you are interested in becoming a trained storm spotter, we do have classes that we occasionally do here in Alachua County. So definitely check our website, weather.gov, and we have a schedule of those classes that we offer each and every year. Again, I mentioned this, the radar site. Not only can you're probably most familiar with reflectivity, but this velocity product, where everything that you see here in green is air that's flowing towards the radar, everything in red flowing away from the radar. Where we get that couplet there, that's where we get a sustained rotation, potentially tornadoes, potentially strong straight line winds. And this is really that part of the Doppler radar that sets it apart from prior radar technology. And obviously here on the end, we can also total up, give an estimate from the Doppler radar, just how much rainfall has occurred. We ground truth that with rain gauges that are on the ground. Sometimes the radar, is running a little hot. It tells us that there's been more precipitation than what's actually fallen. So it's always good to have those ground truth observations on the ground. So again, I think the thing that confuses people the most, we're tasked with issuing severe weather watches, warnings, advisories. People get confused with the difference between a watch and a warning. So if you don't retain any information from the talk here, this is the part that's most important, right? Think about the watch phase. You think about we're past lunch, so everybody's full. I won't rumble your tummy here, but think about you're making a batch of cupcakes. It could be anything. It could be tacos, cupcakes. But the watch phase is when you've got all the ingredients together, right? But you don't have a cupcake yet. You don't have, your tacos done, ready to eat. That's the warning phase. So again, the watch phase is usually This watch area is usually many counties, dozens of counties, sometimes multi-state. The watch phase, again, meaning that all the ingredients are there for either strong winds, hail, tornadoes, those type of conditions. This watch phase will go for 4 to 6 hours, sometimes even longer. If we have a landfalling tropical storm or hurricane, these tornado watches can go up to 8 hours or even 10 hours in length. So the watch phase is a much longer period. When we're talking about a warning, and this is issued by our office at the local field level, that means that we've got the cupcake or we've got the taco, it's ready to eat. Everything has come together, and we try to narrow down that area based on the Doppler radar signature or storm reports that we're getting from the general public. This is called a warning polygon. This shape here in the yellow. So if you're in that area, inside of that polygon, that means that you need to take safe shelter. A lot of folks take that part and say, oh, let me go outside and get a video. That's where folks get in trouble, especially here in the southeastern United States. The tornadoes that we do have are often shrouded by heavy rainfall. They don't really make their appearance known to you until it's right on top of you. Unless you can hear that, that there is that sound, that is true. It does kind of sound like a freight train often. But a lot of folks get in trouble in that warning phase because our human instinct, right, is to visually confirm information that's being told to us, right? That's our instinct. But the message here is to kind of ignore that instinct, get to your shelter, put as many walls between you and the outside as possible. Our warning, that time frame is usually only a half hour, in some cases 45 minutes. You'll never see a tornado warning or a severe thunderstorm warning that's longer than an hour in duration. So we're asking you to shelter for anywhere from a half hour to an hour until the weather has passed, the storm has passed. But knowing the difference between a watch and a warning gets a lot of people confused. So just think about it, in terms of cupcakes. It means you got all the ingredients together. The warning means the cupcakes are coming out of the oven. It's here. And it doesn't mean that every single location inside of this warning polygon that we issue is going to receive, let's say, 60-mile-an-hour winds or, a tornado or large hail. But it means that we think that some location, maybe just a few locations within that area, could potentially experience that severe weather. And again, it's not, when we issue a severe thunderstorm warning, let's say for 60-mile-per-hour winds, our threshold is 58 miles per hour or higher for a severe thunderstorm warning. It's not that a 58-mile-per-hour wind is necessarily going to knock you down if you try to go outside. But what does happen when we get that type of wind speed is we get all sorts of flying projectiles in the air, right? Little tree branches, all sorts of things start to fly around. And those flying missiles, the debris, striking you potentially, your body, cause blunt force trauma. That's what we're worried about, right? Are those flying projectiles and missiles, potentially harming you if you're stuck outside. So the message is to try to get inside, put as many walls between you and the outside as possible. That's usually going to be like an interior closet, bathroom, that sort of deal where you don't have windows, right? Because windows could get struck by those flying missiles, and you could, that wind could get into your home via that method. So again, we're watching thunderstorms when we finally do warm up later this spring and especially this summer. Here's kind of our thresholds. We will not issue a warning for lightning because we just have too much of it, right? This is the lightning capital of the United States. Although last year, because our rainy season was a little more muted, there were a few counties in Oklahoma that actually had more lightning than Florida. I don't know if you heard that story a few weeks ago. But again, lightning, anytime that you hear the sound of thunder, that means that lightning strike was usually within about 20 miles of you. We know that lightning can arc away from the area of heaviest rainfall. So anytime you hear the audible sound of thunder, that also means it's time to go indoors and take shelter because you just don't know. Lightning is a very random and chaotic thing. So while we're not issuing warnings for lightning, you yourself can kind of gauge that. If you can hear the sound of thunder, that means that the storm's getting close enough that you could be potentially struck by lightning. We will issue what we call significant weather alerts for storms that are just under that severe thunderstorm threshold. We can certainly still get tree damage, other type of impacts once we get up above 40 miles per hour. And then we mentioned the severe categories here, anything above 58 miles per hour. If you're wondering what an inch diameter hail is, that's basically the size of a quarter. So anything quarter size or higher, we would consider a threat to life and property if you're caught outside. And then obviously tornadoes are their own classification, own category. And if we saw that velocity couplet via our Doppler radar, that's when we issue those tornado warnings. So again, we're talking about lightning, hail. Again, I kind of went over this already, but the main thing here, when you hear about severe thunderstorm warning or tornado warning, is stay away from windows. If you do find yourself inside, it's not a good idea to shelter in a large type of facility, like a warehouse or gym, that sort of area. Try to get to the smallest room possible. All right, for our tornadic signatures, again, if you look at Doppler radar, the reflectivity part, there's often this hook that you can see on Doppler radar, and then the velocity couplet. But again, getting down to the lowest floor of an indoor structure, staying away from windows, and just having a plan in place. And you can really get a plan in place for yourself during that watch phase, right? That watch phase when we don't have the cupcakes or the tacos ready, the ingredients are there. You should also be thinking about, hey, if a warning is issued, where do I want to shelter from that? All right, so let's talk about hurricane season. We didn't have any landfalling any landfalling hurricanes. We had one landfalling tropical storm in the Carolinas, but no hurricane landfalls this past year. We're really fortunate with steering currents. I think it's a good idea that we name tropical storms and hurricanes because even though they all, to some extent or another, have these hazards, storm surge, strong winds, tornadoes in the outer bands, flooding rainfall, and then all the coastal threats, each and every storm is different as far as the severity of these individual hazards. Some storms don't have a lot of wind. They're tropical storms, but they're really slow moving. They dump a lot of rainfall. That can be just as big of a hazard as a Category 3 hurricane that's weakening as it's coming on shore and it goes by really fast, right? So all these storms are very unique. There's not really one storm that's exactly the same as another. So that's why they get that name, and I think that's a good idea for tropical storms and hurricanes. Maybe not for winter storms. The Weather Channel likes to name every winter storm, but we're not doing that at the National Weather Service. More power to them, though. So again, I like to think of this, our job is science and service. Here's a picture of back in year 2016. I don't know if a lot of you guys were here. Then we had Hurricane Matthew make real close approach to the east coast of Florida. So this is me up in Glenn County, which is the Brunswick area of Georgia, which is part of our area. When we do have these storms threaten our communities, we will send a meteorologist into an emergency operations center for the counties that are impacted. Here's a picture of my colleague, who's now the warning coordination meteorologist for our office, Angela Inietti, briefing back then Mayor Curry in Jacksonville. So we definitely have folks at the Duval County EOC. It's more than 1 million folks in the county, and all the media folks are up there as well. So again, if you are not familiar with our website, please get familiar with it. I think it's weather.gov. If you're traveling, is a good resource. You can see this isn't a current map, but you can see all the the counties that have active watches and warnings and advisories. And then when it's an interactive map. So if you click on Alachua County, you'll get taken to the local page here for Jacksonville. And there's all these tabs here that you can get forecast information. If you're worried about, let's say, the Santa Fe River, you've got river forecasts, climate, past weather, the way, if you click on one of these tabs, you'll get a whole nother list of information. So get familiar with our website. Again, it's the forecast for the next 7 days for your area. And if we have a real big significant impact going on, we'll stick our weather briefing right at the top. So right now, we've obviously got a cold weather briefing for all the freeze information that's happening this week and going into the upcoming weekend. There we go. Okay. So as we get into hurricane season, I wanted to let you guys know that we do offer, if you really want to get into some more of the particulars about tropical storms and hurricanes. We're going to do this again this year. I know that says 2025. We're setting up the website for this as well. But when we get into late July, the way the hurricane season goes, it starts June 1st, ends November 30th. A majority of the activity as far as landfalling tropical storms and hurricanes, August, September, and October. Historically, that's the most active months. So before we get into that, what we call peak hurricane season, we're going to offer, and this is called Florida Tropical Training Week. These are all training sessions that you can log into via computer. They're about an hour in length. We're going to offer 3 of these each day in late July. And we'll once we get the 2026 schedule up, it'll be on our website, weather.gov/JAX. But I wanted to let you guys know about that because I think it could be beneficial to a lot of you who want to learn more about, well, hey, how do I monitor the tropics? How do we get ready for all those hazards, heavy rainfall, strong winds, tornadoes, the sheltering part, right? That can be the most stressful part as all those hazards are going on. And then, of course, the aftermath. And really, when you're getting together a supply kit, getting your plans in place, you're really preparing for the inevitable extended power outage, right? Afterwards, if you don't have a generator, that sort of deal, the post-storm environment is where a lot of folks get injured and in some cases killed because a lot of people, with all the trees down, they just decide to go out and use a chainsaw for the first time in about 20 or 30 years, or they are operating their generator for the first time ever, maybe. And instead of, it being outside, they don't know any better and they put it on their porch. And those fumes get into the home. So that post-storm environment, there's a lot of safety issues with that. So I wanted to let you guys know that we're going to be doing this again this year. We've had a good thousands of people have signed up for this training, and I think it could be beneficial especially if you're new to the area, or even just a refresher, since we didn't have any hurricanes last year, as we go on into the next hurricane season. So with that, here's my email address. If you ever have any weather questions that come to mind, never hesitate to email me. We'll try to get you an answer. If you want to learn more about weather, there's weather.gov/learning. I think it used to be formerly Jetstream, but that's, again, the National Weather Service's way to get more educational information out there for folks. Check out that website. And with that, I'll take any questions, Jane. Thank you guys for having me.
Afternoon. Thank you very much.
Thank you, sir.
So there are offices, yours in Jacksonville, and we got one in Tampa and we got one in Melbourne. So there are several around us. And all of you, as you are in the data collection phase, moving towards forecast phase or I'm not calling it the same thing you did, but
Right.
you know what I mean? I would think that that would involve some judgment.
Absolutely.
And I can conceive that, you know, there's one judgment in Jacksonville and one in Tampa and one in Melbourne. Do you guys coordinate each other?
Absolutely. Absolutely. We are constantly in contact. A prime example of that are what's going on this week with freeze information, right? So we are constantly collaborating with Melbourne, Tampa, and then our offices that are around us too, Tallahassee, Atlanta, about who to include in a freeze watch for the upcoming night. You know, we have a platform that's called National Weather Service Chat, where not only are we collaborating with other offices, but our emergency management and public safety are invited on there as well. So that's a big part of it.
Since it involves judgment, and there are 3 judgments that are occurring here, and you're coordinating it, which is good. Are there any disagreements from time to time, and how do you resolve that?
Absolutely. Yes. Yep. And that it all has to do with who's working, right? It's just like in real life, there's forecasters who are really, you know, kind of leaning forward. I'll put an example out from just a week or two ago. We issued a freeze watch on a Friday afternoon for an event that was on Monday night and Tuesday. Now we usually don't do that, but after collaborating with our offices, everybody thought it was a very high confidence type of forecast. We're heading into the weekend where a lot of folks tune out of the news, and we felt it prudent to do kind of a long, you know, phased, in this case, a watch for sub-freezing temperatures. So yes, it really is depending on who's working. There can be a meteorologist at a neighboring office really, really adamant about, you know, he wants to issue this sort of product or wants to tweak a lot of it. A lot of what we're using now, model-wise, is what we call a blend of models, where we're literally looking at 20 to 30 different opinions about the weather in the computer model world. And, you know, that blend of models, you know, you would think that it would work most times, but there are some times in some situations where a forecaster can feel that the blend of models is out to lunch. We need to tweak, you know, what that forecast is. Up or down, you know. So yes, those disagreements happen, and you know, I think it's a good thing. We do go to conferences. We get to meet face to face with our counterparts in different parts of the state and in other states, and we're also collaborating. You know, I didn't mention this at the beginning. There's regional centers too, right? And there's national centers. We've got, you know, the national center obviously is in the DC area. When we get a big, like with this past winter storm that we had this weekend, where literally everybody from New Mexico to Maine is in a winter storm warning. I mean, that's just crazy to think about the scope of that. That requires a national coordination, right? Not just local and, you know, state offices, but it does require, and there's conference calls that go on at all times of the day. I was listening to a conference call, and I was on those midnight shifts late last week. That's covered areas like Louisiana, the Tennessee Valley. Another thing that we do, not to go ramble on about this, is there are times, let's say, when an office's generator fails and they lose power, or, you know, the weather can cause a power outage. We are equipped to back up neighboring offices, and even offices that aren't necessarily adjacent to us. One of the offices that we back up in Jacksonville is the New Orleans office, which is kind of a nightmare because New Orleans gets way worse weather, it seems like, than we get here. But we are equipped if an office goes down due to power issues or some sort of other technical issue. We practice that all the time. So not only are we collaborating, but we're also equipped to step in. That happened to us. If you guys remember season before last, Hurricane Helene, I'm sure you guys do here in Gainesville. Our office, again, has been there since the mid-90s. The generator failed in the middle of the storm. New Orleans had to take over for us in the middle of the storm. This happened at like 1 or 2 in the morning. and they had to issue all the, you think about everything that was going on with Helene. There were tornadoes in the outer rain bands. Those offices have to be ready at a moment's notice to step in and take over. Now, if there's a landfalling hurricane, those offices will staff up. They'll beef their staffing up if they know. And we knew that our generator was kind of on its last leg. So New Orleans was staffed up and ready to handle a landfalling hurricane.
Some interesting weather obviously coming up from the south and of Florida. And does your weather service extend or collaborate or share data with the Caribbean republics and the others that obviously would be at risk for tropical lows?
Absolutely. Yeah. The National Hurricane Center in Miami, they coordinate with each and every one of those Caribbean nations. And Mexico. The National Hurricane Center is not only the Atlantic, Caribbean, Gulf of Mexico, they also have a responsibility for the Eastern Pacific out by Baja, California, and almost out to Hawaii. So just by that nature, they have to collaborate. And every time, a hurricane watch, a hurricane warning, those are all, suggested by the Hurricane Center, but each one of those individual countries has to give the okay on that. And there's a lot of countries that have their own meteorological staff, but the National Hurricane Center is coordinating with let's say the island of Cuba, which you would think that we wouldn't talk to the Cubans much. We can't fly hurricane hunters over Cuba. That's a big no-no. But Cuba has been hit so much historically that they actually have one of the best meteorological staffs for a small island nation. Very, very experienced folks, and they're also collaborating with the National Hurricane Center.
Thank you, Ben. One quick question. The Gulf Stream. We
Yes.
know how much effect it has on Florida. Have you seen any changes in the Gulf Stream?
Yeah, I would say. I mean, I'm an operational forecaster, not necessarily a researcher by nature, but that is the talk. Like in a warmer world, is the Gulf Stream going to slow down? And particularly, that would have huge implications for Europe, right? They rely on the Gulf Stream at their high latitude, so they don't, freeze and become Siberia. Europe is that much higher up. So I personally, don't have the expertise to answer that. I'm not a researcher, but just my own, observing things each and every, day that I'm on shift. There have been times where I feel like our higher tides in October are a result of changes, in the Gulf Stream, particularly in warmer years. That is certainly a big topic, though, in a warmer world. What's going to happen to the Gulf Stream? Is it going to, is all the melting ice over Greenland and the northern Atlantic, is that going to flood the Gulf Stream with fresh water and shut it down? I think that's an ongoing, topic of research, but I don't think we have the answers yet.
Thank you very much for coming all the way over here to talk
no
to us today. But two-part question. When you have a forecast that says it's a 20% chance of rain, can you say what that really means?
Yes, that's a great question. We get that all the time.
And the second part is, I assume you track what your accuracy of your forecasts are. So how accurate would you say they are?
I know, to answer your first question, when you hear about a 20% chance of rain, a lot of people think that means 20% of our area is going to be covered in rainfall. Really what it is, and this is a little technical, but what does 20% chance of rain mean? Well, for your location, given the exact same variables in the atmosphere, 20% of the time you are going to have what we call measurable rain, which is 1/100th of an inch. It's not a trace, but we can measure it in a rain gauge. 1/100th isn't a lot. I think the other day I got 4 100ths at my house. I was hoping for more. But given the same exact identical meteorological conditions for 1 point on the map, that means that 20% or 2 out of 10 times, those meteorological conditions will produce measurable rainfall, which is only 1/100th of an inch. So that's the technical. As far as verification, yes, we do get scored, verified. Again, our forecast is the next 7 days. I can tell you that our forecast verification overall has improved, especially for the first 72 hours. Once you get beyond 72 hours, we're finding that that blend of models that I talked about actually does just about as well as our forecasts do, days 4, 5, 6, 7. So we're kind of handing the forecast a little bit more over to the computers in the extended range, and we're really hyper focused on the next 3 days of forecasting, trying to get that right. Because again, you think about a watch and a warning, say for a freeze watch, freeze warning, we're usually issuing those products within about 48 to 72 hours out from an event, unless we're really confident, like I mentioned earlier, and sometimes we'll issue stuff that's beyond 3 days out. But yes, our verification scores have improved, especially for that 24, 48, 72 hour time frame.
Our next question comes from Zoom, and my colleague Keith, and I particularly wanted to cover this question. OCAMIC has a COCO RAHS NOAA
yes.
approved rain gauge and report our rainfall here at OCAMIC every single day. We got 1/10 the other day. Does the National Weather Service use these data from us and the many thousands of other such rain gauges around the U.S.?
Absolutely. I've got a COCO RAHS rain gauge in my backyard. I like to know how much rain fell in my yard, for mowing purposes, especially in the summer. But yes, we are looking, if you're not familiar with COCO RAHS, it stands for Community Collaborative Rain, Hail, and Snow Network. That's what that acronym stands for. Yes, there are thousands of people who are doing this. We get a nice interactive map that's published each and every morning when all the observers, if you join COCO RAHS, they generally like you to report your rain gauge total once a day, whether you've had rain or not, and that data gets plotted on a map, and we use that data quite a bit. We also, there's some observers that, when we have a particularly heavy rainfall event, relay that information on the COCO RAHS website, comes directly to us at the National Weather Service. So yes, we absolutely use that data, and I am a proud COCO RAHS participant, have been for over 11 years. I'm a big proponent of just having that ground truth rain gauge. Doppler radar is great. Sometimes it overestimates, sometimes it underestimates, and having that rain gauge network is vital. Yes.
Thank you again for coming. When we're having a hurricane, they talk about two models, the U.S. and the European.
Yes.
Can you tell us what the difference is between the two, and also where does the European model collect their data from?
So, computer models are very sophisticated. Now we're getting artificial intelligence versions of the European, artificial intelligence version of the American model. It's all very complicated. The differences in the European model versus the American model are what we call data assimilation. It's the way that they interpret all of the satellite data, the weather balloon data. Each and every time an airplane takes off, that data gets also ingested into the computer models. So that's why it takes supercomputers to ingest all of that observational data. Every once in a while, there's a bad weather station or two out there that's giving you erroneous data. So the difference in the models is what we call data assimilation, how they're taking that observational data, plugging it into all the equations that govern our atmosphere. Immense amount of physics. You think about all the data points around the world. You need a supercomputer to try to calculate everything. So the difference between the European and the American model is what we call data assimilation. And a lot of people think that the European model has a better data assimilation scheme. That doesn't mean that it's always right. But there's many more models out there, particularly when we get into like the shorter term, like I mentioned, day 1, 2, and 3. We have regional models that are a little bit more focused, like the European, the American model. Those are what we call global models. They're looking at the whole Earth. But we also have real specific shorter term models that we're using as well, that run every hour. The American model, European model, those models run every 6 hours. And again, the big difference is in the way that the data is assimilated, and there's some differences in the whole equation too. go into it.
It's amazing how accurate the weather prediction has gotten, even to predicting the low temperatures during this cold spell, right on the nose pretty much. But in March of 1993, there was an event
Superstorm.
that was later called the Storm of the Century that caught people in this area totally by surprise.
Absolutely. Yep.
And I wondered if the way that storm developed was so totally unusual that it also kind of caught the weather forecasters by surprise as well.
Yeah. So, I mean, in 1993, I was 16. I'm dating myself. I was 16 years old. I was a big weather nerd. In Virginia, we got a pretty good snowstorm out of the storm of the century or superstorm or whatever. So that was kind of a really rare conglomeration of everything came together. This past weekend storm was impressive in its scope, right? But not everywhere was heavily impacted. This March superstorm impacted a good part of the country. Where I was up in Virginia, it was snow and some ice. Down here, huge, what we call squall line of thunderstorms with that low pressure center kind of diving into the southeastern U.S. If you were north of the low pressure, like in Atlanta, Birmingham, they had, several feet, a foot or so of snow. But down here, we had a really intense line of thunderstorms move across the Gulf, so much so that there was storm surge. You think about storm surge with hurricanes. There was enough wind ahead of that big line of thunderstorms in the Gulf of Mexico where we had 10, 12, 14 feet of storm surge out by Cedar Key, areas along the Gulf Coast. It was a storm surge event in the middle of, in spring, coming out of winter, but from a wintertime type of storm. I would say that storm overall, on a nationwide, everybody knew it was coming, but the individual details, I don't think anybody forecasts, 10, 12 feet of surge along the Florida Big Bend and West Coast in that event. So it did take forecasters by surprise. Again, that was, decades ago. I'd like to think if we had a similar setup with an intense storm like that, the modeling would do much better in this day of age. But I do remember that was a very overall well forecast storm, maybe not in Florida, just because of the aspect of the Gulf surging out ahead of that line of thunderstorms. We had all sorts of tornadoes in that squall line of thunderstorms. That was a really big event nationwide, but I think a lot of the fatalities from that event were on the west coast of Florida from that storm surge.
Yeah, at Horseshoe Beach. I was actually on Seahorse Key at the time. At a few days before, they knew, and they just told us to leave and get off the island. So it was forecast, but they didn't expect
the extent
of it.
Right.
There's two questions on Zoom about the funding for NOAA
yes, politics.
and the National Weather Service.
So our office, I can only speak to our office. We were really lucky. A lot of folks opted to retire early or take a buyout at the beginning of the administration about a year or so ago. We, our staff of 20 or so, we only had 2 folks out of 20 leave. Now, other offices, absolutely decimated. Think about out in Kansas. I can think of Goodland, Kansas. Was really heavily impacted down. They went from a staff of like 20 down to about a staff of like 6 or 7. It's really tough to keep up a 24-hour operation with only a handful of folks. So were we impacted? Not as much locally. I think it was just by luck. There were a lot of offices that were heavily impacted. Thankfully, a lot of that went away, and we're actually hiring now, which I don't think a lot of federal agencies can really say at this point, but there was pushback on that, I think, from nationwide. And we're slowly, as an agency, starting to recover from the big, there's In our agency, there's about 4,000 people nationwide. We lost, 600 or 700 folks, either through early retirements or, some staff reductions. So we're starting to slowly get those numbers back.
And the place in Colorado, the research?
Yes. Then again, I was just talking about, the 122 offices that I had up on the map. Yeah, the research arm of our agency, absolutely devastated. I don't know if that's going to come back. At least it's slower as far as hiring, like at the National Center for Atmospheric Research out in Boulder. They lost a lot of positions out there. A lot of folks, took the early retirement, the buyout that was offered to them. So that the research part of this was hit a little bit more heavily than the operations part.
Good planning. Okay, well, thank you so much. You really
Thank you, guys.
appreciate very much your visit and found it very interesting. Next week, we have a talk by two of Bob Palmer and Jerry Kirkpatrick are going to talk about the effects of weather on history. So that will be next week.